Hey guys, if just want to talk to you about maximums and minimums and how this will help you, say, for projectile applications or profit scenarios. But if you are on your book on page 208, I'm just going to read the problem and kind of walk you through it. We have a person who's throwing a ball up in the air, and that ball releases from that person's hands at 8 feet. And we know, based on some physics, that the ball's projectile motion follows the path of s to the t, s being distance, t being time, of negative 16 t squared plus 48 t plus 8. So if it was graphed, we're looking at something like that. It's exaggerated, not to detail, but that's a kind of idea. And as what we would like to know is at what height is the maximum and how long did it take to get there. And then we'd also like to know how long is the ball in the air from here to here. Well, this is kind of easy to solve because we're just going to find the vertex. So to find the vertex, we do the opposite of b over 2 times a. So that's negative 48 over negative 32, which is 3/2. So the ball to reach its maximum height takes 1.5 seconds. So at 1.5 seconds, what is the height? Well, you plug in to the original equation 3/2. And we get as an answer 44 feet. So in 3/2 of a second, we get 44 feet. So our vertex gives us our maximum. What also needs is in that same equation, we also want to know how long is the ball in the air. Well, to do that, we just need to find out what its zeros are. And if you go back to my very crude drawing, we know it starts at 8 and comes over. We don't really care about this in particular because that we start at 0 for time. So we just need to find the positive 0. Well, to do that, we could factor out a 16, or factor out an 8, and get negative 2t squared plus 6t plus 1 is equal to 0, so that we can use the quadratic. So negative 6 plus or minus 36 plus 8 over negative 4. So negative 6 plus or minus the square root of 44 over negative 4. And you can simplify it further, but basically we're going to get our positive number to be 3.16 seconds. So hopefully that'll help you with your word problems tomorrow.